This is the browser extensions with Flutter talk. My name is Kaylee. Now, hang on. My clicker's not working. All right, we're gonna have to go old school here and actually click with the mouse. Fun times. Okay, there we go. My name is Kaylee. I am a senior Flutter engineer at Kashish. Before I was at Kashish, I worked at a video company, primarily building a browser extension. While I was doing that, I was actually in React and not in Flutter, but transitioning over to working in Flutter, I got to bring all this awesome browser extension experience with me and use that in my new role. I am a Flutterista. We have, yay, some awesome Flutteristas here. The Flutter community booth has some information. I'm also doing a panel tomorrow evening with the rest of the Flutteristas, and hopefully you'll come and see us there. Cool, let's get started. So today we're going to be talking about what browser extensions are, how various projects can benefit. I have some examples to go over and some code. It's a lot of code and we're gonna go over it fast, but there will be a QR code with a fully built out GitHub repo for you to look at and follow along and learn later on your own. And then hopefully, fingers crossed, we have some time for questions. Okay, so what are browser extensions? Does anybody here use browser extensions? Yay, cool. Has anybody ever built a browser extension? We got one in the back. Awesome. What about in Flutter? Yeah, so that's just me. So there's basically three different types of browser extensions. Browser enhancements, so these are things that make the browser itself change or how it appears to you. An example is AdBlock Plus. I think a lot of people, if they have any sort of extension, usually AdBlock Plus is a good starter there. Utilities, these are things that the user does that helps them do a job. Example of that would be like Grammarly, helps you with spell checking, AI writing, and actually injects different visuals into the browser. And then finally, product enhancements. Zoom has a great one where you can schedule meetings on the fly using your extension. And my company has our extension in which we manage web payments. So one thing when you're thinking about whether to build an extension in Flutter, there's a lot to consider. And the biggest thing is how the extension, what your product is actually doing. So with AdBlock Plus, behind the scenes, what it's doing is it's intercepting network calls so that the website that you're loading never actually reaches out to that ad server, and then no ad is displayed. It can also read the web content and intercept and change the render. So instead of seeing an ad, you'll see an ad is blocked by AdBlock. Good for Flutter? Probably not. Almost all of that happens on the background. It's very silent. There is a UI, but the UI is not very reactive. It's more just like configurations. It would be so much extra work to do it in Flutter with very little payoff, so not a good idea. Grammarly has AI injections, does a lot of stuff in the background, but there is pieces of the UI that are fairly reactive and interactions that the user can do that sits on top and can move through. So is it good for Flutter? Maybe. My company, we primarily use ours to replicate and enhance the mobile experience. We do use third-party or content scripts to interact with the third-party apps. For example, if you're purchasing something from Target, you can press a button in our extension and it will grab the purchase total for you, so you don't have to fill that in. So is that a good example of something to use with Flutter? Since we're here, we're going to say yes. So why is certain things a good idea and a bad idea? So like I said before, you have background actions that tend to happen very silently, foreground actions, and then this content injection that sits in the middle. So AdBlock Plus uses these three things, service worker DOM manipulation and network interception, that cannot happen in Dart. Those are JavaScript actions that, JavaScript files. They have to stay JavaScript. You can't write them in Dart. Reactive UI, absolutely can use Flutter for that. Could also use JavaScript. And same code for mobile and web. Flutter all the way. That's obviously a super big pro for all of us. And then sitting right there in the middle is content injection. That is something that can sit on either side. There's silent content injection that happens in the background, and there's also user-triggered actions that will inject content that sits on the foreground, say like a button that grabs a total from a website. So if you're going to think about using it, you want to think about what is your primary function. So for today, we're going to build an example app, an app that I came up with that I think is a great kind of starter idea into thinking about this as a bookmarks app. I don't know about you, but I have, 10, 11 different profiles that I log into my browser, one for work, one for personal, one for throwaway. And keeping the bookmarks the same across all of them is very duplicative. And so with an app, you could keep those bookmarks in a database and access it on your various devices and platforms, regardless of how you're logged in. So our basic app has to talk to the database. The mobile side you could share from the browser to grab those URLs, and it also has a clickable list that opens to an external browser. You all know how to do that. Those are pretty basic Flutter functions. For the extension, we want to be able to listen and respond to browser events. Now this means that when a user is working and wants to add, they click this little star up here. That's how they would normally add, or through the bookmarks manager or through the tab. And we're going to set up a way where it does this automatically. So the user doesn't have to think about it. They just add the bookmark and it adds to their app. Second piece of that is a clickable list. So we can actually open the bookmarks that we have. So these two things as part of the extension is what we're going to focus on today. Okay, so getting started, we're going to assume that you all already have a Flutter app going, that you know how to do that. You will need Node. And TypeScript is not necessarily a requirement. I personally recommend it just because there is a little bit more type safety in working with a language like Dart. That's extra awesome. You will need the Chrome types library for that. I use NPM, do whatever you want. Okay, so the first thing we need to do is look into our web directory, and we need to make some changes to our index HTML file. So right up here at the top, you'll see our HTML tag. There is a style min width, min height. That is required. That is going to set the size of your pop-down window where your primary user interaction will happen. I have a background color on there. That part is not required. That I like to do so that it helps with debugging. It helps kind of see if there's any holes in your Flutter code, things that are peeking through. It's just a little bit easier. And then next, down here at the bottom, you need to get rid of all the Flutter bootstrapping scripts. Everything needs to go and needs to be replaced with main.dart.js. We're going to talk about a little more of that in a little bit, so we'll get there. Okay, so next we need to create our TypeScript directory. This is where all of our TypeScript files are going to go. When we later transpile them, they are going to get copied into our web directory. There's two files that we need to worry about here. The manifest.json is in the Chrome docs. We're not going to go over how to do that. They're pretty standard. There's a few things that need to happen. Specifically, we need to edit the content security policy with the WASM unsafe eval. This is really important because, so just to back up a little bit, I don't know how many of you are kind of up on what Google's doing with some of the web build aspects of Flutter, but the HTML render tag is being deprecated next year. And right now, the HTML tag is the fastest and easiest way to build in a Flutter application into an extension, but when that goes away, you will have to use this. Also a note, this does not work in Safari, but the HTML render does work in Safari. Moving on. So our Flutter bootstrap that we removed from our index HTML has now moved into this Flutter bootstrap JS. Most of it's pretty standard. We just have added in this loader. And what this loader does is ensure that the local copy of CanvasKit that is built during the build phase gets used. Typically, during the bootstrap process, it actually uses it as a CDN and gets the CanvasKit. This way ensures that the local one is always used, because remote code is not allowed for extensions, no CDNs. This also goes for Firebase, by the way. Just as a side note, you will have to build something separate for Firebase. Everything else in the web folder, you don't need. It goes bye-bye. Okay, so because we've got two different stacks going on and some other things, I recommend using a build script. It gets kind of onerous to try to type in all of your commands all the time when you're working. So this covers all of it for you. So one command does it all. First, transpiling our TypeScript into our web folder. The second one, the node script. This one is not required, but it is something that makes my life so much easier. Basically what it does is it marries the information from your pub spec into your manifest. So say your pub spec is version 2.3.1, it copies that version over into your manifest, so you don't have to change. If you're using flavors, you can use this script to copy the relevant flavor details. So if you have different icons or different descriptive text, you can use this script to do that. I have it here in JavaScript. Doesn't have to be in JavaScript. It can be another shell script. It could be a Dart script. Do whatever you want. And then finally, we have our Flutter build command here. It is in web. Notice we have two flags. The CSP, Content Security Policy flag, and the No Web Resources CDN. These are both required. They both ensure that content security policy is honored and that at no time is the app trying to reach outside to get remote information, remote code. Let's see, is that, oh yeah, hot reload, hot refresh. With extensions, they have special permissions, so they only run in an extension context. Your access to the Chrome API only runs in extension context. So while you could make visuals render, you can't perform the same actions that you normally would in your debug runner. It's still useful to use the debug runner when you're doing styling, but what we'll get to a little bit later, you want to run that so that it skips over your actual Chrome API. Similar to with Flutter, when you're running in debug mode, if you change certain assets and do certain things, you have to quit and rebuild, and rerun. So this works very much in the same way with load unpacked, which is what you use with the extension. Okay, the Chrome API. Now, for this talk, we're referring to Chrome. We do acknowledge that Safari exists, and we'll get to a little bit more about Safari, so TypeScript is one side of it. TypeScript is where all of your background and silent behaviors will be happening. You will need your own libraries, so if you, say, have a logger that you have in your Flutter code, you will need to have an equivalent JavaScript logger in your TypeScript code. Same thing goes with Firebase. Currently, Firebase only has authentication as a JavaScript library that is not instantiated with the script code. They do plan on expanding that. Creative workarounds is kind of the name of the game there, but you will need your own libraries. TypeScript can send messages to Dart. On the Dart side, this is where our UI is. This is what the user is interacting with. This is where we use our JS interop library, which we're going to go into a little more detail next. And it can send messages to the TypeScript side, so you can have some communication there. Safari. Using the Xcode converter is the easiest way. So if you want to jump into the land of building extensions, it's best just to build it for Chrome and then convert it over. Can't really go the other direction. So use Xcode. They come as a combined app, so web and Mac OS gets built together, or you can do web and iOS together. The API is basically identical, not everything though, so it's important to check that out. All right, let's go. So the first thing, our first goal was to listen and respond so that when somebody clicks the star, we get our bookmark added. So this is on the TypeScript side. We're not going to go into super detail. This is the service worker. It's basically a fancy index of event listeners. There's a few other things that you can do with it, but the primary function of the service worker is to be event listeners. They don't stay alive for long. They only wake up when needed, so you don't want to put anything that needs to be long-lived in there. All this is in the documentation. Chrome API has very good docs, so you can learn about those there. We won't go into detail. All right, the interops part. This is the fun part. So this is the second goal for us. We're going to build a clickable list that has, when you click on it, it opens up in a new tab. So the extension lives in its own context, and trying to navigate normally doesn't work. So if you want your extension to function as a bookmarks tab, you want it to open up in your browser. So for that, we need the Chrome API. So we're going to talk a little bit about the library, go over some methods and a little bit of magic that we do with those, and talk about types. Before we get into that, it's important to talk about fakes. Some of you know them as stubs. I like the word fakes because I think that's way more fun. Everything that you build in your interop library must have a Dart counterpart so that we can do conditional imports. So we accomplish this, I think, in a much easier way by using an index and put all of our conditional importing in there. You don't have to do everything all in one index. Split it up however it makes sense for you so you're not loading in 100 things all the time. This makes things so convenient so you don't forget and accidentally import JavaScript code into mobile things and make your whole app blow up, which we don't want. So highly recommend putting it in an index, but conditional importing here is very important. Anybody who's done this before used to see this being dart.library.html. That is gone. Now we're using JS interop, and it does the exact same thing. Okay, so building out our library. We do need the JS annotation on our Chrome here. Chrome is the top level, and we only need it on the top level. And we're going to grab it out from the JS side. And then we have to define what each of them are. So we have our extension type built on implementing the JS object. Tabs is a sub API from the Chrome. Another example would be storage. If you wanted to use local storage to help with that, that would also live under here. So any of the sub API sections would go under Chrome. You want to build your library out identical to how, identical to how it is in the Chrome documentation. So our method, here we have our tabs, which is our sub API, and we have one method that we're using, which is the create method. This create method opens up a new tab, and you can set various functions. So that's what our create properties will decide how it's opening our tab. That includes our URL. Do we want it to be a pinned tab? Do we want it to be active? Those kinds of things we can set in there. It's important to notice the types here. So we have a JS promise returning a JS object. So that's going to be important later. Don't forget, you need your fake. I use unimplemented error. You can do unsupported error. Throw whatever you want, make a custom one. Doesn't matter, just so long as it doesn't try to run. None of this should ever get called, but just in case. Okay, so our methods. So here we're using the tab method, the create one that we just discussed. So now here's where things get a little bit tricky with the JS interop. So we have Dart in our properties, and we need to take that Dart, convert it to JavaScript, put that into the library that we just created, our API, send that JavaScript to the API, which returns JavaScript, and turn that back into Dart. So clearly, this toJS object, toTab, those don't exist. Those are methods that I have created that we'll get to next. That's where the magic happens. And again, don't forget your fakes. Okay, so this is where the fun stuff happens. So here we have this JS object helpers on map. So you can just do .jsify on your map, but that converts to a JS any, and it can get expensive and not really do anything helpful. And we know we want this to be a JS object, so we're just going to typecast it as a JS object. We're doing this as an extension method because it is kind of two-step, and we're going to be using it a lot. So save yourself some code time and make some extension methods. Second one's a lot more complicated. The Chrome API returns always a promise and always an object of some sort. There's a few exceptions that are not an object, but for the most part, it's a promise returning an object. But we know what these are. They are very clearly defined in the Chrome documentation, and we know what we're using and what we need. So we're only gonna build out what we're using and what we need. And so we're creating our own type that sits alongside the JavaScript type. So the type that we're creating is the tab type. So if you want to create a tab, it's going to return to you the details of the tab that you just created. So what we want to know the ID of the tab, the URL, and whether it's active or not. And you could build in whatever's useful to here for you. So this first line here, this toDart, this one, that first one is converting from a promise to a future. It doesn't touch the contents of that promise into a future. So that is still going to be actually a JS any is what it returns. But we don't want to keep it as a JS any. We know it's an object, so we just typecast it as an object. Next, we have to actually pull each of those properties out. They're not iterable in a way that's useful. It is much easier to be very deliberate and just pull out what you need and what you're going to use, and use the Dart.js interop unsafe to do these conversions here and convert them to a Dart property, or a Dart type, excuse me. And then you see at the bottom, we're actually returning a Dart type, which we create. So I tend to keep those all in the same file just for cohesion, but you can do it however you want. But you must have those types defined in Dart as well. Okay, so using these methods that we created is pretty straightforward. We do need to keep things separate because we have mobile and web that don't play nice to each other. There's a lot of ways to do this. My favorite way is to build a base class that is unimplemented. It just saves a little bit of errors. Some people choose to have their base class instead be their mobile class and have that be their default. There's nothing wrong with that. This is just how I like to do it. I'm working with 4 different platforms, and this just saves me a lot of heartache, but you do you. But importantly, we have a web implementation, and this is where we call our tabs methods. Now, if you have these all in the same file, it's still going to be doing that conditional import. So this is where we're importing our index. And so if you're doing a mobile build, it'll just do the fake, and since this is the web one, you're not even calling it anyways, so it doesn't matter. But as you can see, this is all in Dart and returning our Dart tab class that we created earlier. Again, a little note here that we're just printing it out. This is a good idea to do when you're working with the Chrome API for your own sanity. If you're having troubles, 99% of the time it's a type problem, and when they don't print and print what's happening, it's going to be a type problem, and you'll see it. So when I was doing this presentation, I actually had a bug with that and discovered it because I printed the tab. So very, very highly recommend doing that. Okay, let's see. Oh, yeah. Mobile and test, build them as you will. I also use my test implementations for dual purposes. For running tests, tests can't use the Chrome API, but when you're running in debug mode, you can set it to use the test implementations and actually debug to some degree with the Chrome API, just not actually using it. And then here, using your services and your widgets, we all know doing the injected dependencies and service locators and all that stuff. I didn't do that here just so that you can see what's going on, but obviously use your favorite libraries to do that. As you can see up here, this is for rendering using the test implementation. I've got KSWeb and KDebug mode. That ensures that you get that test implementation when you're running in debug mode. But again, do it how you want. And then down here, our open link that we created in our controller is using the appropriate implementation. All right, last but not least, a couple of notes. As I said before, only use the run for UI and styling. Chrome does not work out of context. The web rendering is slightly different, so you'll have to make some styling changes. I'm not going to go backwards to my bookmarks app screenshot, but the bookmarks on the app bar sits justified on the left for the mobile and sits in the center for the web. So you may have to make some adjustments for styling. Use flavors as you normally would. We use Firebase, and for that I use separate targeted main builds because Firebase initializing at all in there will get rejected from the extension rules because that would be remote code. Navigation and extension does not work. It is not the same. There's a lot of different solutions out there for that. I personally built my own. It was so much easier than trying to figure out how to cobble some other library together, but you will have to think of some kind of, rethink your solution there. Anybody who's worked with extensions know that one of the most difficult parts is figuring out where your debug statements are going. So that is also true with Flutter. They're everywhere. Take time to understand that, and you'll save yourself a lot of trouble. And the documentation here is actually pretty outstanding. Chrome has done a really good job, and it's extensive, absolutely extensive. But because of that, and because it's such a big endpoint, it is also why there aren't a lot of super great reasons to use a built library or package. There does exist some packages, but yeah, build them your own. Anyway, I'm over time, so that's it. Documentation for both Chrome and JS Interop was the entirety of my source for this presentation, so there's a lot of information gleaned from there. This QR code builds out both the tabs implementation and storage implementation. There's a lot of extra detail in there, so I highly recommend it. And that's it.